Hey, welcome back. This is 1.9 on distance, midpoint, and circles. I think you'll find this a lot easier than the previous sections. So here we go. First off, distance formula. The most basic distance formula is the one for finding distances on the number line. So let's say -5 is here, 4, -3, -2, -1, 0, 1 is right here. Okay, is that right? -4, 3, 2, 1, 0, 1. Okay. And let's say I want to find the distance between -5 and 1. The formula for doing that is just the absolute value formula. So the distance between any two numbers, x and y, is x minus y, absolute value of. So the distance between -5 and 1 should be absolute value of -6, which is 6. Okay, and of course you can count, right? You can go 1, 2, 3, 4, 5. Oh yeah, it is 6. Okay, so that's the most basic distance formula that we have. And you've been dealing with absolute values, but you never really probably thought of it as a distance type thing, but it is. Okay, distances are always positive values, and that's why that absolute value thing is a neat trick. Okay, anyways, that's the first kind of distance formula. I've left myself no room to write anything, but the distance formula we want to work with, so maybe this is A, the number line. The distance we're interested in is in the plane. Okay, so distance basically in 2 dimensions in the plane, or if you'd rather, 2 dimensions. Okay, so let's take a scenario, right? We have 2 points in the plane here, and what do we do? We say this is at 1, 1, and then maybe 2, 1, right? 1, 1, and then 2, 1. One way to kind of measure the distance is literally just to measure this length, okay, which you could use the absolute values to get. So that length would be x, well, we could put it in terms of real numbers this time, right? So let me get my eraser here. The distance between 1, 1, and then this point here is at 2, 1. That distance just is the difference between the x values, right? So 2 minus 1, which is equal 1, is that distance. And then we could also find this distance here. So that distance there would be the difference of the y values. This should be 2, 2. So that would be 2 minus 1 again. Okay, so that's one way to kind of get an idea of their distances, but we usually think in direct distances. So in particular, maybe in a different color, I want the distance in a straight line from the first point to the second point. Okay, so this is, we can get this because this is a right triangle, and we know the Pythagorean theorem basically says if you have a right triangle, and you have this side and this side and this side, then a squared plus b squared is equal to hypotenuse squared. So if we know the length of the first side, and the length of the first side is 1, and then we know the length of the second side, which is also 1, we can just square those, and then that will equal the square of the hypotenuse. So 1 squared is 1, 1 squared is 1, c squared, flip-flop sides. And c squared must be 2. The square root property says c equals plus or minus root 2. When we're talking about distances, we only want the positive distance. So c equals the square root of 2. And that turns out to be the distance between these two numbers. Okay. Let's make this now into a formula. And so we could say that this first point represents some x1 comma y1. And then the second point represents some x2 comma y2. Okay, so we're kind of using Pythagorean theorem to figure out, let's call the hypotenuse d instead of c. So d squared will equal sort of the difference between the x coordinates, which is what this thing was from above. So x2 minus x1, and it's the distance, so it's an absolute value thing, and then square it. And then plus the distance between y2 and y1, the y coordinates. It's an absolute value because it's distance. Of course, when you square something that's an absolute value, it won't, the absolute value is positive, but when you square anything, it's going to be positive. So what we do to make life more simple is just, hey, let's drop those absolute values. And we get this x2 minus x1 squared plus y2 minus y1 squared. Okay? And then in this part of it, where we're solving in the last step, we do the square root property. So that's what we'll do here too. We'll say d is equal to then the square root of x2 minus x1 squared plus y2 minus y1 squared. And it really has a slope type flavor to it. Slope is all over the place. This is the change in y, right? This is that change in y thing. And then this is the change in x. It's just instead of having a ratio, we have a sum of the two. Okay, okay, so that's just an observation. It's neither here nor there. This thing that I've given you is the distance formula that you need for the first set of problems. If nothing else, you're basically just plugging and chugging. WebAssign will really challenge you with some crazy numbers. Let's just keep it easy at first. So let's try -4, -1, and then 2, -3. Okay? So the distance will be the square root of x2 minus x1. So 2 minus -4 is plus 4 squared, and then plus -3 minus -1. So it would be -3 plus 1, ultimately. And then we could go square root of 6 squared is 36 plus 4 squared is 16. And then, well, sorry, 4, that's -3 plus 1, that's 2. And then square it, that's 4. Sorry, I try to do too much in my head today. It's going to end up being 4. Okay? So that will be square root of 40. And then we want to simplify our squares roots. So this is square root of 4 times 10. And then we could march the 4 out. Square root of 4 is 2. And we get 2 root 10 for the distance. Okay, okay, that's the first formula. The second formula is the midpoint formula, which basically finds the middle of any two lines. So if you look back at this picture, this yellow picture, the midpoint, I'll put it in blue, looks like it's probably right here. So I need a formula to figure out that point. Okay, so the midpoint formula, oops, I'll put it in white. Again, you're dealing with these 2 points, x1, y1, and x2, y2. How do I figure out the midpoint? Well, you're going to take the averages of the coordinates. So the average of the x coordinates, and then the average of the y coordinates. So it's just the sum of the coordinates divided by the number of coordinates. And there's 2 of them, so you divide by 2. Okay, let's look at one from homework. So again, they're going to be giving you weird fractions. They'll give you radicals, just anything to make your life more difficult. Okay. Okay. So we're substituting these numbers into the midpoint formula. So x2 plus x1 are those guys. So I have -2/5 plus -2/5 all over 2. And then we add these together. So that would be -4/15 plus 7/15 all over 2. Okay. And then -2/5 plus -2/5 is -4/5 over 2. And then -4/15 plus 7/15 is 3/15. That thing is 3/15, and 3/15 is 1/5. Okay, so it's 1/5 all over 2. Okie dokie. We don't want to leave our answer like that. That's bad news. Those are complex fractions. So what do? You multiply by reciprocals. So -4/5 divided by 2 is the same as -4/5 times 1/2. And then we have 1/5 divided by 2 is the same as multiply by 1/2. Okay. So 2 goes in the 4 2 times. We end up with -2/5. And for the second guy, it's 1/10. Okay, and that's the midpoint. Okay. From here, we can get a formula for a circle. And what is a circle? It's the set of all points that are equidistant from some center. Okay. So it's a set of all points of distance r, the radius, from a center point, which they usually call h comma k for some reason. Okay, so the picture then, we have our hk right here. It's a set of all points that are some fixed distance away. Okay, so some fixed distance r. So it'll turn out to be, if you were to kind of rotate that r around the center, you get the circle. Okay. To get the formula of the circle, you use the distance formula, because all of these points, so for instance this point, which we could call x comma y, if you find the distance from this point to the center, which is h comma k, you kind of get a formula, right? So the distance from xy to hk we can find by subtracting the x coordinates, x minus h squared, plus then subtract the y coordinates. So it's a set of all points xy that fulfill this equation. Okay? And then we square both sides, get rid of the square root, so we'll have d squared. Instead of d, we have r in our case. So let me get rid of that d. It's no longer distance. We're talking about this fixed number r. So we'll have r squared equals x minus h squared plus y minus k squared. And usually they write it in the other way. They write it with the x part in the front, x minus h squared plus y minus k squared equals r squared, where h comma k is the center and r is the radius. Okay. Okay, so it's, where does that equation come from? It comes from the distance formula. Okay, so what do they want us to do with this? They want us to create some equations, circles, given information. It's just like when we created equation of lines, right? So write the equation of a circle given, so this is an example, given the center, let's put C for center, is 2, -1, and the radius is 4. So what are we doing? We're plugging this information into this formula here. So we'll have x minus h, so this is h, this is k, x minus 2 squared plus y minus -1 would be y plus 1 squared equals 4 squared, which is 16, and that'll be our equation. Okay. Another version is in the other direction. So they give you an equation and want you to find the center and the radius. So find center / radius. Okay. So x plus 1 squared plus y minus 4 squared equals 25. Okay. So if you put it into kind of the standard form, it's x minus something, right? So to make it plus, it has to be -1. And then y minus 4 is just equals 25. So your answer then for the center is going to be -1 and then 4. You could think of it as taking the opposite signs of what you're originally given. So if you're given +1, it ends up being -1. If you're given -4, it ends up being +4. And then the radius, you just have to remember to take the square root. Okay, so it's not 25, it's actually 5. You could draw the thing. So -1, 4. Let's maybe go up a little bit more. So we have, okay, so -1, 1, 2, 3, 4 is here. The book is going to, or the homework's going to want you to note the domain and range. Okay, so 1, 2, 3, 4, And you can get that by drawing it. So it's going to go up 5. The radius is 5. So from the center, go up 5 and down 5. 1, 2, 3, 4, 5. That gives you the range. Okay, so the range, I should have done the domain first, but the range will go from -1, that bottom point is on location -1 on the y-axis, and it goes all the way up to 1, 2, 3, 4, 5, 6, 7, 8, 9. For the domain, then, you're going back and forth from the center. So you're going over 1, 2, 3, 4, 5, okay? And then you're going 1, 2, 3, 4, 5 in this direction as well. Okay? So the x-coordinates are 1, 2, 3, 4, 5, 6, -6 to 1, 2, 3, 4. Okay, in general, for the domain and range, you're just kind of moving back and forth from the x value or the y value, up and down. And then you can connect the dots and you got your picture. Okay, if I'm going too fast, I apologize. You can always pause the video and okay. There's one more issue I need to deal with here. The general form of a circle. So generally, it's not going to be given in that appearance. Okay. And there's a lot of kind of these formulas which represent what you'll later call the conic sections: hyperbolas, ellipses, circles, parabolas. Okay, and they all have this kind of form to them. And so you'll be given something that maybe looks like this, and you kind of have to put it into the form of a circle or a parabola or whatever. So how do I do that? Well, you have to complete the square. Okay, so let's take a look at maybe 1 or 2 examples. So I have x squared plus y squared minus 4x minus 12y minus 9 is 0. Okay. So I'm going to collect all the x stuff together, and then I got to complete the square. So I'm going to add in something, and then the y stuff, and then I have to add in something, and I move the 9 to the other side. So I have plus 9, and then the stuff I'm adding in. If you add it in on one side, you have to add it in on the other. Okay. Okay, so kind of set it up as a fill in the blank. On the left here, on the first set, it's negative b over 2a, where the b value is whatever's in front of x here. Okay. So it'll be negative 4. It's not negative, sorry, it's just b over 2a. Okay, squared. Sorry. So the formula for completing the square, it's always b all over 2 squared. Okay, so in our case, it's negative 4 is the b, all over 2, and then we square it. Negative 4 divided by 2 is negative 2. And square that, that's 4. Okay, so that goes here. The second one is negative 12 all over 2 squared. Negative 12 over 2 is negative 6. That'll be 36. And of course, if I add it on one side, I got to add it on the other. That completes the square. So factor it. Factoring these polynomials. 9 plus, that's 49. Okay, so the center is 2, 6, and the radius is 7. Let me do one more example, and then I'll call it quits. And again, I'm sorry, I feel like I rushed in this video. I apologize. Okay. So again, I'm going to get the sort of the x stuff. Well, there's only the x squared, and then I get the y stuff together, and then I have to complete the square on that y part, and then I move the 7 over, and I have to complete the square. You got to add stuff on both sides. So for the first one, negative 6 all over 2 squared is negative 3 squared, which is 9. Add it there, you got to add it here. Okay. and then factor it. So x squared just stays x squared, and then plus y minus 3 squared equals 16. So the center, what is the center? It may be, well, I don't know what the x center is, right? I don't know. But you can pretend x is the same as x minus 0 squared. And then you see, oh, the x coordinate for the center must be 0. So the center is 0, 3, and then the radius is 4. So you wouldn't write this form. It's this would be sort of your equation of a circle. It would be silly to put the x minus 0 there. Okay, so that's the big and the small of this section. I'll leave it to you, and thanks for watching, and we'll see you next time.